we have Jeremiah and the Ferris wheel. All right. So Jeremiah boards the Ferris wheel at 6 o'clock position and patiently waits for the rest of his passengers. Blah, 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 blah. Okay. So guys, that's irrelevant. Of course you're boarding at the 6 o'clock position, right? A Ferris wheel has a platform, and then here's the 6 o'clock position. Everyone gets on there. When the ride begins, Jeremiah is in the 3 o'clock position. So this is where he is at t=0. Okay, so they're trying to confuse you by saying he boards at the 6 o'clock position. That is not when the ride begins. So they're boarding people. When the ride actually starts, he's over here. And he's traveling clockwise. So he's going down. He reaches the 12 o'clock position. So that's up top. After 2 minutes and 15 seconds. So in minutes, that's 2.25 minutes, right? 15 seconds is 1/4 of a minute. So please don't write 2.15. That is very, very, very wrong. You need to be able to convert seconds into minutes and so forth. Same thing with minutes into hours and things like that. At his highest altitude, Jeremiah is 62 feet off 62 meters. So then there's a typo down here. This should be meters. So I apologize for that. Off the ground. When Jeremiah is even with the axle of the Ferris wheel, so here's the axle of the Ferris wheel. The axle's in the center, and that's what makes it spin. He is 36 meters from the ground. So that's here. He's 36 meters off the ground. So that means also at the 9 o'clock position, he is 36 meters off the ground. Okay, so we're sort of filling this in here. He completes 2 full rotations and whatever else is necessary to return him to the boarding area. Okay, so let's see. Okay. Here, the 2:15. All right, so we've got a lot filled in, but we still need to figure out a little more. So this is my biggest hint here, the 2 minutes and 15 seconds to get to the 12 o'clock position. So that was 3/4 of a period, right? It was from here to here, here to here, and here to here. Okay, so 3/4 of a period took 2 minutes and 15 seconds, so 2.25 minutes. So if we want to figure out how long the period was, what's one full circle, I'm going to solve for period. So I'm going to multiply by 4/3. And you guys do have access to a calculator here, so you can just multiply by 4/3 in your calculator. The answer is going to be 3. So the period is 3 minutes, which means the interval is 3/4 or 0.75 minutes. Okay, which would be 45 seconds. Okay, 0.75 minutes is 45 seconds. All right, so the next thing I have to figure out is some stuff that has to go down here. So if I have my interval is 45 seconds or 0.75 minutes, that means this is 0.75. I'm going to go up by 0.75. That's 1.5. So if I did this correctly, this should be 2.25, and it is. And that means at 3 minutes, when I finish my first period, there we go. Oopsies. At 3 minutes, I'm back at an altitude of 36. So this is working out perfectly. So the last thing that we didn't figure out, this is parentheses here. The last thing that we have to figure out is what is my altitude down here? So we need to find out what the amplitude is. So if this went from 62 to 36, the difference is 26 meters. So that means the difference between the axle and the bottom of the Ferris wheel also has to be 26 meters. So my amplitude is 26. The amplitude is always going to be equal to your radius. So to get the altitude down here, I'm going to do 36 minus 26, and I get 10. Okay, I also know my midline is even with the axle, so the midline is 36, and there is no horizontal shift here, so I am ready to write my equation. So it's y equals 36. Now let's think about it. If I start here and go down, I go down, up, up, down. That's a negative sign, right? I start down, back up, back to the midline. So I'm doing a negative sign graph here. So 36 minus 26, sine. I need my b value. If the period is 3 minutes, b is equal to 2 pi over the period. Well, the period's 3. So 2 pi over 3 x. There's no horizontal shift here because we started directly at the 3 o'clock position. So let's give ourselves a little sketch. And again, guys, you can hit pause at any time if you think I'm going too fast. So I have to do a sketch that shows his entire Ferris wheel ride. So I know the interval is 0.75 minutes. So this is 0.75, 1.5, 2.25, 3, 3.75, 4.5, 5.25, and 6. So I'm going to stop for a second. I'm not done yet. I want to go back and read. It says Jeremiah completes 2 full rotations and whatever else is necessary to return him to the boarding area. So if the period's 3, 2 full rotations takes me to 6 minutes. Okay, so I'm there. So he did 2 full rotations. So he started here. He did 1 full rotation, a second full rotation, and now we need to do whatever is necessary to return him to the platform. So that's 1 more interval, right? It's not a full circle. It's just 1 more 0.75. So I have to go out to 6.75 because it says write a trig function and sketch a graph that shows his entire Ferris wheel ride. So his entire ride is 6.75. It does not end at 6, which is where 2 full waves would end. We have these values. This is 62, this is 36, and this is 10. So we're ready to start graphing. All right, so we started here at t = 0, down, and at 3 minutes I finished 1 full circle, so that makes sense. So then he went around again. He did 2 full rotations on the Ferris wheel, and then whatever was necessary to return him to the boarding platform. So that's why we have that extra little piece at the end. Okay, so there's my graph. It shows his entire Ferris wheel ride, and I have my equation as well. So I just got full credit for number 1 there. I have the correct equation and the correct graph, and I showed his entire ride. If you had only gone out to 6, you're not getting full credit because you didn't show the entire ride. And that's going to come in handy in one of our questions coming up. So number 2, what are the first 2 times that Jeremiah will be 50 meters off the ground? So usually when we ask you questions like this, we are asking, like, what are the first 2 times he's 62 meters off the ground? And it's one of these 3 main y value points. But now it's not. Okay, so like 50 meters is what? Right about here and right about here? Well, I don't know what time that's happening at. And nor do I want to say 50 equals and solve this, right? I guess I could and solve for x because I'm looking for a time. You guys don't know much about solving equations yet. We're going to do that soon. I mean, it is possible to solve that algebraically, but no, I don't want to do that. I would so much rather, since I have access to my calculator, use my calculator to help me. So take out your calculators right now. I'm going to open mine here. Okay, so I want to type in our equation. So the first thing I'm going to do is I'm going to go into mode and double check that I'm in radian mode. So make sure you are in radian mode. And then let's type our equation into y equals. So if I remember correctly, it was 36 minus 26 sine. Oops. I tried to type sine and I should have hit the button. Sine. And it was 2 pi x over 3. And then I have to delete this over here. So let's delete that. Okay. All right. So let's just double check. 36 minus 26, 2 pi x over 3. Perfect. And I'm in radian mode. The only thing else that I need to do is, usually when we graph these things, we have our grid set up like this. This is our window. The x value goes from -10 to +10. The y value goes from -10 to +10. Well, that doesn't help me here at all. You guys can see my window should be whatever my axes are over here. So I'm going to make my x-axis go from 0 to 6.75, right? I have my interval right there, and I'm even going to make my scale go by 0.75. You don't have to do that, but I feel like doing that with my interval. And then for my y values, I don't care about negative y values because this Ferris wheel does not go underground. So my y max, I'm going to go up to 65. Okay, you could stop at 62 if you want, and I'll just make my scale be 5. It doesn't really matter what you do for the y scale. So once I hit graph, since I'm in radian mode, I should get, as long as I came up with the correct equation for my graph, I should get something that looks exactly like my paper. And it does, right? So this is one way that we can check ourselves right here. But now I need to answer the question, when are the first 2 times that Jeremiah will be 50 meters off the ground? So I still don't know where the y value of 50 is over here. But I could I could put it on there. Right? So I want to see where is the y value equal to 50. So y equals 50. So I'm going to go into y2, and I'm going to put a second function in there. Okay, and if you remember from Algebra 1, y equals a number, y equals 50. That's just a horizontal line. So let's see what happens now. So now I have this horizontal line, and it shows me exactly what time, exactly where the intersection is for when the Ferris wheel is 50 meters off the ground. So you remember from Algebra 2, you were able to calculate maximums, minimums. So let's take a look. Second, calculate. And I'm going to calculate, I don't want to calculate a minimum or a maximum. I want to calculate option 5. I want to calculate an intersection. Where do these two curves intersect? So what you want to do is, since we want the first two times, we have to find the first two intersections, is you want to go as close as you can. So it has you on the first curve first, the sine curve, to the intersection in question. You're going to hit enter. And then the calculator thinks it knows which intersection you're talking about, but it makes you click another point on the horizontal line. So I'm going to click again. And then it has a guess for you, but if you click one more time, it's going to tell you where the exact intersection is. So you have to click enter 3 times. So the intersection takes place when t is equal to 1.77 minutes. Okay, so I'm going to put that over here. So I'll start answering number 1 down here. So it happens when t is equal to 1.77 minutes. And then let's go back and let's calculate the other intersection. So second, calc, intersect, 1.77 was the first one. So now I want to bring my cursor over to the second intersection, and it doesn't have to be perfectly on it because the calculator is going to figure out what you're asking for. And this happens at 2.73 minutes. So those are the first 2 times that you're at an altitude of 50 meters off the ground. So I did not solve for x over here. I did not want to do that. Instead, I used my calculator to help me. I'm sorry, that was the answer to number 2, not number 1. So number 3 over here, what are all the time intervals when Jeremiah is below 14 meters off the ground? All right, so 14 meters is like right here. Oopsies, I wanted to be in, oh, I am in pink, is right here. So we're looking for a time range, okay, because it's looking for intervals. So there's an interval that takes place there. There's going to be an interval that takes place here when I'm 14 meters off the ground, right, from here to here. And then last but not least, and this is why it was so important to graph his entire Ferris wheel ride, there's going to be an interval over here where he's 14 meters off the ground. Okay, so we're going to have, this one's a little bit of a pain in the butt, this problem, because we have a lot of intersections to calculate. So I don't care about 15 meters off the ground anymore. I'm going to go back to my calculator, and I'm going to change my horizontal line to 14. And let's see what this looks like. Yep, it looks exactly what I thought it was going to look like. So I have to calculate these intersections. So second, calculate, intersect. I'm going to go all the way to the left to start. Come on. There we go. And the first one takes place at 0.48 minutes. T equals point. Actually, you know what? I'm going to change my wording because it says, what are the time intervals? So I'm going to say it's between, oh my goodness, between T equals 0.48 minutes and let's see the ending time for that interval. Let's find it. Second calc. So I want to calculate this intersection. 1.02 minutes. So that's the first interval that I am below 14 feet. So the second interval, I have to calculate the next intersection group. Oh. Okay. There's some loud bird in my backyard. Second calc. Intersection. $3.48. I'm going to try to make it so that this stops. There we go. And now let's calculate the second one. Second calc. and 4.02 minutes. And that makes sense. It's a full period away. 4.02 minutes. But I'm not done yet. I have this last interval over here. So let's find that last intersection point. .48 minutes. Between t equals 6.48 minutes and the end of the ride. Or you could say 6.75. Any of those is acceptable. So guys, you got to know how to use your calculator. I am not helping you with pushing buttons in your calculator during a quiz. This video is here to help you learn how to use your calculator to help you. I'm not going to do this whole second problem, but I just want to make something clear about hours since midnight. Okay, so draw a graph and write an equation that represents the boat's height above sea level since midnight. So notice how we say 2:45 a.m. Okay, so if we're talking hours since midnight, I'm not going to put 2:45 on my x-axis, am I? No. Okay, so hours since midnight, 2:45 would be 2.75 hours since midnight. Okay, and then the other one we have is 2:15 p.m. So if we're going to talk about hours since midnight, that's going to be 14, that's somewhere over here, 14.25 hours since midnight, okay? So please, please, please do not be putting 2:15 on your x-axis label. That is very wrong. Our x-axis is labeled in hours since midnight. All right, guys? When it says, what will the boat's height be at midnight? I'm just going to show you one last thing that you can plug in here. So the other thing you can do is second calc, and you can just calculate a value. So if I want to know what is the value at midnight, that's when t equals 0. Now this is not the right equation, so this is not going to be the right answer, but you would just do second calculate, and you calculate a value, which is option number 1, instead of calculating an intersection or a minimum, things like that. And then what will the boat's height be at the next midnight? Well, that's not t equals 0 anymore. That's t equals 24. All right, guys, I think I've talked long enough. For those of you that cut class today, I hope you are sorry. I'm joking, but I hope you do watch this video. And it helps you. You guys can expect some sort of a large trig quiz coming up. Probably not the next time I see you, but the time after that. All right, adios.